Hi guys, in this video I'll be talking about logistic regression. It's an algorithm in machine learning that you can use with classification. So yeah, let's get going. So let's talk about the linear regression algorithm before getting into the logistic regression algorithm. So I'm in Paint 3D and I'm just gonna draw here a linear. Oh, wait, I'm in Eraser. A linear regression model. So what does a linear regression algorithm do? What does it do? Um, Let me just do that. Right. So the linear regression algorithm, what it does is that it draws a best fit line for some data points, right, guys? These data points are just some outliers. So the best fit line would look something like this, or something like this, or something. Right? Well, that's a sloppy arrow. Right, guys? I mean, that is the linear regression algorithm. But what is the logistic regression? What is the logistic regression? Well, pause down in this video to just think let's guess what a logistic regression is. So, yeah, pause the video and yeah, come back if you have a answer. Great. Well, maybe you're right. Who knows? So let me just draw a quick coordinate plane. Wow, forgot to label the axes. So this is the x, this is the y. So what the logistic regression algorithm does uh, is that it has a Boolean kind of value. What I mean by Boolean kind of value, it has it has like data points that have a yes or a no kind of answer, while the linear regression algorithm can have plenty of answers. So by that I mean that uh, that let's say that you're doing a survey on how many people like broccoli or not. That would then the best if you want to do a machine learning algorithm on it, you would rather use the logistic regression algorithm because it's good for yes or no kinds of answers. But if you have like if you're doing a survey like what's your favorite ice cream flavor, um you can have like any answer, right? It could be chocolate, it could be vanilla, it could be strawberry. But so that's why it's like lots of data points. So that's why linear regression algorithm would be best for these kinds of options, for those kinds of options. So let's talk about the logistic regression algorithm now. Let's say that let me draw like a quick table like over here. So let's say that this is 0, this is 1, right? 0 means no, 1 means yes. So let's say you're doing a survey on how does it. Let's say that you are doing a survey on if a person likes broccoli or not. So first grade, 10 people like broccoli, and let's say 14 people love broccoli, but 10 people did not. Now let's do second over here. Let's say that 5 people did not like broccoli, but 20 people did. Finally, third grade. Let's say that 6 people did not like broccoli, but only, let's say 20 people liked broccoli. So, but how would you plot this on a graph? If you were to plot it, it would look something like this, right? Or something similar to this graph. Am I right? Like something similar to this graph. Well, what the logistic regression algorithm attempts to do is that it does the same thing like the linear regression algorithm. it what do you call it, draws the best fit line for this one as well. But it does, so let me just draw the line. But it's not like that. That's not the line that you're expecting. So if you were to like dig into the mathematics of this formula, this line on like the logistic regression algorithm, it would have a formula of y is equal to BO plus B1 times X. I'm pretty sure. Yeah, yes. So this is the line, but if you were to add this to a sigmoid function, right? Sigmoid function. Come on. You would get this sort of line. So let me just erase not 1 pixels. So let me just erase this line a bit. It would look something like this. No, not like that. Okay, so it looks something like this, guys. You get it? The line, instead of like going straight, since it's like only 2 answers, it goes like this curve over here. So what is this sigmoid function? I'm gonna get deeper into this mathematics. The sigmoid function is basically equal to P. So okay, so let's say that P is so the sigmoid function is equal to P is equal to 1 plus 1 over 1 plus E, and this is gets subtracted by the Y. That is the sigmoid function. And if you were to add this to the this value, this, you would get this sort of graph right here, like that kind of graph. So yeah, that's like the logistic regression. But I want to make sure that logistic regression is not a regression algorithm. It's for classification. Yeah, so there's like one last thing that I want to say to you guys, that uh this function is basically the so let's say that in linear regression you would do y is equal to mx plus b, and that where m is just equal to y2 minus y1, and that's over x2 minus x1, and the b is just the y-intercept. This function right here, no, this formula, not control C, oh my gosh. So this formula is just added basically to the sigmoid function, which is this one, right, guys? So this formula is kind of like added to the sigmoid function to make up the logistic regression. So I hope you understand logistic regression. In the next video, I'll be teaching you how to implement a logistic regression algorithm using probably of a student dataset that I will be creating on my own. And yeah, I'll be providing the dataset in the link. And yeah, see you guys later. Bye, guys. See you guys later on Shrimp and the Prodigy. Bye.